My name is Jonah Berquist. I am the engineering manager for the database infrastructure team at GitHub. This talk is about our new online schema change tool called gh-ost. You may not have heard of GitHub, especially if you weren't here in the last talk that was by Shlomi, who had the same slide as I do here. We are a company that produces a lot of stickers and t-shirts and water bottles and hoodies, and also have this like side project about like Git hosting and software collaboration. That's pretty cool. It really helps drive the sales of the t-shirts and the stickers. So I think it's pretty great. So you're here to learn about gh-ost. gh-ost is our new schema change tool. It stands for the GitHub Online Schema Transmogrifier. This is actually true. We were developing it, and we were just calling it like gh-ost for online schema change. But gh-ost is so close to gh-ost that gh-ost is obviously the better name. Had a little bit of trouble coming up with what that T stood for. Transmogrifier is my favorite. We developed gh-ost over the course of the last year, slightly more than a year. It was February of last year that we got together and came up with the idea, and now we use it in production daily, and it is all open source online on github.com/github/gh-ost. First of all, I do want to say, like, it's not a panacea. There are still limitations. We've been trying to document them as we find people coming to us and saying, like, hey, what about this thing? Do you support that? Often it's a, no, we don't. We don't actually have that type of setup in our system. But, you know, if you'd like to help support it, then we're definitely happy. We've had several things come in, like RDS support came in this way. Off the top of my head, I don't remember. Point being, there are still things that don't work. So if you're doing stuff like this, keep that in mind. Check out the limitations page for the latest things that do and don't work. A little bit of context. We run MySQL at GitHub, and apart from the Git data, MySQL is where we store all of our data. Not all of it, most of it. But repository metadata, users, pull requests, all of these things that you think of when you're seeing data on github.com, that's not Git data. It's very likely coming from MySQL. So we expect our service to be fast and our throughput to be high and our latency to be low. gh-ost is something that helps us with that. Migrations are something that have been pain points for us and for everyone, really, I think. We all know that, like, if you just go and you run an alter table, if your table is big, you're going to see a lot of locking for a long time. There are like new versions of MySQL where you're not going to see that locking immediately, but then you're going to see replication lag while that replicates through. So there's a clear need for online schema change tools, and a lot of it's been addressed for a while. 2009 is when the Oak online alter came out. Most people, I think, these days are using PT Online Schema Change. We were using PT Online Schema Change for years. It worked really well for us. I note Facebook's Online Schema Change here because it has a slightly different implementation than PT Online Schema Change, which I'll get into a little bit more later. Point being, we need our migrations to be able to run. We can't block things, and we can't take down github.com to do it. Which is to say, we have taken down github.com doing migrations in the past using PT Online Schema Change. So there were problems with triggers. the way that triggers work, you have writes coming into a table, and then those writes have to happen not only in that table, but in another table. And this builds up the number of threads that are running in your database. We were noticing that that was causing stalls in the worst case scenario. When we had super high concurrency, we got to a point where we had risky tables. There were things that we knew we could only migrate this table like off of peak hours, or there were some that it was at a point where we thought, okay, well, this had a problem when we ran it off of peak hours on a weekday, but if we run it on a weekend, it'll be fine. And we were still always concerned because we wanted to make sure that if a migration failed, that everything was cleaned up. And sometimes it wasn't. So we would have someone like keeping an eye on things, making sure that if there's a risky migration running, that that if it goes wrong, then we can take action and like drop triggers. We had chat ops we still have chat ops to drop triggers. We don't use them anymore. But we used to drop them. We would see a migration would cause a load spike, and we would say, oh shit, we better drop those triggers, make sure they got dropped, because we want to get back to our normal load. So here's the way that something like PT Online Schema Change works, the way that the OpenArcKit Online Alter Table works. LHM does the same thing. You put in triggers that grab all the inserts, updates, and deletes that come into your table. They do replaces, deletes, and replaces, respectively, onto your ghost table. Ghost table being the word that I'm going to be using for the table that you are. That's the new table, right? So your original table, then you got your new table. You're doing your alter over there. So it's called the ghost table. It's real scary and it exists in the. No. All right. Okay. So the thing that happens here is anytime there's a write on your original table, there's a write that's happening sequential, like but synchronously on the ghost table. And if there's lots of inserts or updates or deletes happening, you're going to have a lot of the trigger writes happening on your ghost table as well. So you're essentially doubling your write throughput or your write load on the cluster as a whole. There's some ways to get around that. Well, okay, so Facebook does something slightly different with their online schema change. It's still doubling the write load synchronously, but it is not doing it into the ghost table. All of the inserts, updates, and deletes are triggers that are just doing inserts into a changelog table. So this reduces the contention on the triggers, because instead of having to deal with inserts, updates, and deletes, and then replaces and deletes, it's all just your normal traffic and then inserts. And we all know that if you're just doing inserts, your performance is going to be a lot better, right? If you don't know that, trust me on that. So triggers have problems, right? They're stored routines. They're interpreted at runtime, so they're slow, right? They add latency to every transaction. We're talking adding latency from like the point that you are doing whatever operation you're trying to do. It then also has to interpret that and then do that operation on your ghost table. Yeah, so locks as well, right? Lock contention can be a big problem. The more interesting thing that we start getting into when we think about like what if we didn't have triggers are the fact that in order to throttle something like PT Online Schema Change, you still have to leave your triggers in place. If you remove your triggers, then you have to start over. So I'll come back to that. Another thing is we were thinking about running migrations concurrently. Like if there were a bunch of things that we wanted to happen all at the same time, there was no way that we were going to put like dozens of triggers onto a single box at a time. Like it was not going to happen. Another thing is that you can't really test your alter table with the same traffic levels that you're going to have in production, right? Because the triggers are generating the load that is doing the copy for all the updates that are happening when your migration's ongoing, right? So, right, I didn't mention that there's the triggers part, right? And then there's also the backfill part. So there's the whole process of, while these triggers are in place, the reason that they're in place is so that you can copy every row from your original table to your ghost table, right? So that's why big tables take a long time. It's not just you put triggers up and then magic happens, right? So it's a matter of the long-running jobs to copy all those rows, and then what's the extra load going to be while that's happening. So we've got some problems, and we want to get away from those problems. By the way, that plushie there is for sale right now, shop.github.com. It's real cute. I mean, you can get one. I mean, look at it, right? Just look at it. So we were in New York. We were in New York like a year and 2 months ago, and we were sitting around having a team summit, talking about like how we've been having these problems with migrations. Basically, the conversation that we had is what I was just telling you all, and we were thinking, well, what like the implications of this are that all of the inserts go to that changelog table, and then later they're taken out of that changelog table and put into the ghost table, right? So you copy all your rows, and then you process the changelog table. The changelog table is literally just a list of everything that has happened on your original table, which is interesting because we have something that is a list of everything that has happened on your original table, right? It's your binary logs. It's what you use for replication. So Ghost takes advantage of that. Ghost connects as a replica to a server. We'll come back to that. And it looks for every insert, update, delete that you do, and then it transforms them to meet like the new structure of your table, and it applies them to the ghost table, right? And then it also goes ahead and does the whole iteration, copying through all of your rows all at once, right? And then there's a little bit of extra work that we're doing just to like say, hey, we've started this migration. Here's kind of where we are. So there's an extra table, two tables, one table. Well, okay, so there's the one, and then there's the lock ones, which, all right, don't worry about those. So here's what this looks like then. Instead of having triggers between our tables, we're using that binary log, and then Ghost is reading from the binary log and applying to the Ghost table. All right? So that's interesting because now there's nothing that's happening sequentially or synchronously between these tables, and in fact, everything that is going through the binary log is then being applied sequentially to the Ghost table. All right? So that's cool, but this is cooler because there's no reason that we have to have Ghost looking at the binary logs on the master because we can get the binary logs on the replica. Question. Okay, the question is, have I already copied the data over, or does that come second? And the answer is that it happens at the same time, only not exactly at the same time. So it is happening the whole time. So what Ghost is doing is it is, I think that I might have a slide that I'll get to it. All right, so what I was saying, right? This is cool. This is cooler because now Ghost is looking at the binary logs on a replica and then applying changes to the master. That means that there's one less connection adding extra load to the master, right? So the binary logs could be anywhere, right? And Ghost can take care of everything that it needs to. And Ghost can throttle, suspending everything that it is doing, including that work to keep up to date with all of the incoming writes to your production table. So now, I mean, as long as you've got those binary logs around. If you're keeping them around for a while, probably not a problem. If you have very little, then, maybe. But, yeah.
Have you measured a difference between pointing Ghost at the master bin logs versus the replica?
The question is, have I measured a difference between pointing Ghost at the master versus the replica? And the answer is no. Have not thought to measure that. Because, so two points, right? One is that for a while, so right now we have, most of our clusters are now row-based, right? But for a while, like, there's a statement-based replication happening on the master, but we still want to use Ghost. That's fine because we can change to row-based on like one box. So it's not just a performance thing, it's also a can we actually use it or not. The other part to the story that I wasn't finishing was that it doesn't work with statement-based replication. This is why when we were talking about like, oh, could we use the binary logs as a changelog table, we thought, oh, no, like not. Shlomi looked at me and he was like, I already thought about that, Jonah. Can't be done. But that's because it was statement-based replication back when Shlomi wrote the Oak online alter. So then you'd have to like parse all of the SQL, figure out where everything is happening with row-based. It's literally just a list of everything that you've got. Did we talk about this? Yeah, so we can pause everything, right? Everything is happening sequentially, right? So if there's a lot of writes happening on the master all at the same time, happening on that table, it doesn't matter to Ghost. Ghost doesn't care. Ghost is not going to try and write all of those to the Ghost table all at the same time. There's no need for it to do that. The server that you're migrating is only going to see one connection from Ghost, and it's just issuing a ton of writes on this table that nothing else is even talking to, and it makes it really lightweight as far as like what the master sees. So the basic flow of a Ghost migration is that you've got your original table, Ghost creates the Ghost table, it alters that table, it hooks into the binary logs, and then it starts listening to the replication stream, and then interchangeably starts to apply events that it's getting from the replication stream and copying the rows over. So it does that as long as it needs to. It prefers to apply the events as it has them. It'll keep around, default backlog is like 100. It'll like parse that far ahead in the replication logs, and then it'll say, all right, I'm going to do this for a while, and then I'm going to go and copy things for a while. The fact that we're not doing them at the same time means that like we've really simplified a lot of the logic that we might need for worrying about race conditions. So we do these steps, and then when it's time to cut over, we cut over. More implications about cutting over later. So we use the connecting to a replica doing all this work on the replica, checking out like how big the table is, what the table looks like, counting rows on the table, and then writing to the master, doing heartbeats on the master, expecting to see them on the replica, and then, so it's basically this picture, right? So there are other ways that we could do it. We could just connect to the master, right? So what we were just talking about was A. We could just do B, or we could do C. C is interesting because we're only talking to a replica. And I'll talk about that, not in this slide, but coming up after we look at this sweet, sweet AutoCAD figurine. This is the miniature version, although it could be the larger version if that were a very large cactus. Available now. shop.github.com. All right, so what I want to talk about is like why I trust Ghost, right? And why I trust it not only as much as what I've been using for years, but actually more. And one thing is that we can test. We can test, and we do test. So there's unit tests, there's integration tests, whatever. Ghost also tests in production. So going back to this, we can run something that is only talking to one replica. That's cool. We could also just have like a bunch of those running on a set of dedicated replicas, not to scale numbers here. But we do, on our largest cluster, we've got like 3 dedicated Ghost testing boxes. And what they're doing is going through every table that we have and just doing a trivial engine equals InnoDB alter. That is very interesting because it's actually using the same workload that it would be doing if it were a real migration, right? It's reading the binary logs. It's exactly what it would be doing. And it's applying the changes that it's getting out of the binary logs. And it's copying all the rows. When it's done, instead of renaming both of the tables and flipping them around, we just stop and we leave them there. And then you can go ahead and just like check that they look fine however you want. Select MD5 some star from each one. It should be the same, right? Check some of them however you want. And make sure that they're the same. And if they're not, then something's wrong. Early on, we found like a couple of bugs with like weird timestamp things and stuff like that doing this. At this point, we've migrated literally every table that github.com has, I don't know, dozens, hundreds, probably hundreds of times. It happens all the time, and we don't notice it really. We just know that like if it fails, then there's something wrong, and then we need to go and look at Ghost, and also then we would need to make sure to not run migrations on that table until we figured out what was going on. But we trust it because we know that it's happening all the time, like this. We trust it because we can throttle it. So there are different ways we can throttle it. We can throttle it based on like how hot the master's running, right? Our thread's running high, right? That's normal stuff. Replication lag, is it lagging a lot? We can throttle it, right? That's normal. We can also specify like some query. You could say like, oh, when this happens, then throttle, whatever. There's a HTTP endpoint for like if you've got some API that like you want to hit that, and it can say like, hey, now would not be a good time to do writes, then throttle on that. Put a file somewhere and it'll throttle, or you can like literally just talk to the Ghost command, the Ghost process on a socket and say, hey, throttle. So at any point, if you think that the migration is causing a problem, you can stop everything that it's doing and then resume it. In practice, we used to do this. We used to use the command to like freak out. We'd see a load spike and we'd go, oh, just that ghost. Better stop the migration, because we were so used to migrations causing load spikes. These days, what happens is we'll see some sort of spike or some sort of like increase in replication lag, and we'll say, oh shit, is that ghost? Should we throttle it? And all we'll actually do is say, hey, ghost, what are you doing? And it'll say, I'm throttling. Because it's already doing it. It knows, like, oh, there's replication lag, there's a spike, whatever it is, ghost is already going to be throttling. So we trust it a lot. The other place to trust it is at the cutover phase. I don't know how many of you have done a migration and you've thought, all right, this is going to take maybe like 8 hours. So maybe I don't want to start it at 5 o'clock. Maybe I want to start it, tomorrow morning, and then it'll be done at like 5 o'clock, and I'll be around for the whole thing and around at that cutover point, because that cutover point, that could be dicey, right? So we did that too, right? We want to stick around, and maybe you say like, all right, well, maybe I'll kick it off in the morning and then go into work, and then I'll be there at work when it's ready, or something like that, right? So we don't worry about that anymore because we postpone cutovers by default. This is something that we just tell Ghost to do, like, hey, check out if there's that file there. If there is that file there, then don't do the cutover until someone tells you to do the cutover. So what Ghost does is once it finishes copying all of the rows, it just keeps looking at the binary log, looking for writes coming into that table, applying them the same way that it's been doing the whole process, and it just keeps doing it. It's cool. It says like, hey, we have it fire off some hooks, so that like there's a message from Hubot that like is saying like, hey, that migration's done. I'm just gonna keep going. And it's ready whenever you're ready. So that means like, yeah, I can go to bed. I can like not worry that the migration cutover is gonna like happen and I'm gonna get woken up or anything weird like that. So hooks, right? So that's what I was talking about there. Were the like about to cut over hooks. But we also have hooks that are there and can like just have a lot of information being put wherever you want. We're GitHub, we use chat ops a lot, so a lot of stuff is just going into chat. When it's starting up, it says like, hey, so-and-so's doing this migration on this table, kicking it off. Early on in the process, we'll say like, here's kind of what it's looking like, and then we kind of back off and say like, all right, here's where it is periodically, just because we like to see that something's happening, and if something went wrong, we want to know like that I could. So like every half hour, Hubot is saying like, here's the brief update of like where we are, what percent, what time we think we have left, and so that's something that's just nice to have that we can just look at it anytime. Nice. This is interesting. This is a thing that we don't use at all, but we thought we might, and we built it in, and it's something that essentially you can sleep between every time that Ghost does something. So say like, oh, all right, I want to run like 10 of them. Maybe I should just like say, sleep 10 times whatever, right? Or you just say like, all right, just throttle more. Just because you think you should like not because any of those other reasons that I talked about were telling you to throttle, just like throttle just because do it. We don't do it. We started doing that, and really we found that it's not necessary because we actually rely pretty heavily on this. So we have millisecond granularity replication lag, and we just look for that. And Ghost is aggressive in looking for it, and it will throttle it when we see replication lag. And this is good enough for us. Between replication lag and like threads running, those are the only things that we actually throttle on. As well as like if someone said, hey, throttle. So yeah, like 5 seconds is kind of a lot of lag. Like 10 seconds is like a lot of lag. And if there's like a spike of 20 seconds of lag, someone's going to be looking into it, right? So we keep things pretty low. This is one of my favorite graphs, although it's a little misleading. So this is showing replication delay on a production cluster on an extremely busy table during peak hours, sometime last fall. There are some spikes there, though this is not filtering out the hosts in the pool that are not actually serving traffic. So there are like analytics boxes, there are backup boxes. Those are the ones that have those large spikes. The rest of it, you can see that before we start the migration, there's like no lag, right? It's, if you can't see the y-axis here, the top number is 5 seconds. The bottom, so there's 0 and then there's 0.5, so that's 500 milliseconds. So we were significantly below that. We start up the migration and like, yeah, all right, we're getting like 500 milliseconds. Some things are lagging up to like a second, but those aren't really the boxes to be concerned about, right? What's this? I don't know. Probably adding a column or an index or something like that. It doesn't really matter as far as like the operation of Ghost is going to be the same. So yeah, at the end of it is something that's kind of fun. You can see that we just set the max lag milliseconds to something even lower, and then the lag went away even more. But we don't actually set it that low because then migrations actually just take forever. And 200 milliseconds versus 500 milliseconds, like our app should be able to handle like 500 milliseconds of lag, right? So with this whole theme of like why do I trust it more, how do we like tell it to throttle? I've been talking about like, oh, so we want to be able to have control over how the process is running. With something like PT Online schema change, you might think like, all right, here's the configuration that we run migrations for, and it like we use this threads running, we use this these various throttle things, we do this chunk size, and maybe some of those are like daytime thresholds, and maybe some of them are like off-peak hours thresholds, but you get through the daytime and then your migration's still using those earlier thresholds and it like isn't going as aggressively as it could be. Ghost, that's not a problem. Ghost, we can say, hey, change that variable to this and configure it dynamically. So if we are saying like, hey, have this niceness at whatever, and then we say, yeah, all right, this niceness thing doesn't apply at all, but we're like 3 hours into a migration that's going to last 2 weeks. Do I want to like start it over? I don't really, especially not if like instead of 3 hours I was like 3 days in, right? So we can just set things dynamically. We tell Ghost like, hey, change that variable to this. We also have it so that we can like ask it like, hey, what's going on? And that is in our world, that's like in chat, we're talking to Hubot saying like, hey, what's up with the migration? We can also, you know, throttle it that way I've mentioned, change the max lag milliseconds. It's all just a matter of like, when you're watching it and you see how it behaves and it's doing something that it's not supposed to be doing, you can change it at the time. So these are things that are on this slide because I need to make sure to talk about them, but I think I've already talked about all of them. The migration cutover is how we do that cutover through chat ops, so we can actually see like when it's triggered and who did it and like why, like whether there was anything that happened immediately afterwards. I know that I have actually fairly recently seen something where I did a cutover and then saw some spikes, and they turned out to be like the buffer pool was cold because this was like a migration that had run for, I don't know, a week or something, and like some of the older things had fallen out of the buffer pool on the ghost table. So it was interesting to like correlate directly with when that happened versus when I said, hey, migration cut over. The other thing is that like everyone can see what's going on. Anyone who wants can say like, hey, what's the status of the migration? Does it have a while to go left? Like, I'm really interested in this one because like this is my migration and I really want that column, and like as soon as that's done, then I'm gonna get so excited and ship my feature, right? So instead of saying like, hey Jonah, hey Shlomi, hey Tom, how's that migration doing? We can say like, oh, just run this command and you can see it. So it's cool. Here's an example of Shlomi cutting over something that was running for like 12 hours. So Hubot's saying like, oh, here's how it is. We're at like 96%, and then it's ready to code over in the next message. And it mentions Shlomi, and then Shlomi says, all right, cut it over. This chat ops is slightly out of date because now we also supplied the table name to that cutover command in case we're doing more than one at once. But then it's complete. So that water, like, let me tell you, available now. We've got some things that are on the roadmap for Ghost. Some things that like we're thinking about doing, and some things that we think are cool but aren't necessarily like going to do. So one thing is that this row copy still has the old table and the Ghost table on the same server because the row copy is doing a select and an insert into. But Ghost is like just looking at the binary log. So what if Ghost didn't copy directly between the tables? What if Ghost read the rows and then inserted them? Well, that's interesting, right? Because then it doesn't even need to be on the same box. We can reduce the load on the master by not reading all the old rows from the original table on the master. We could go and read them on some replica that has lots of extra capacity, and so it's just going to have that extra bunch of selects going, and then Ghost is going to read them, and then it's going to go back to the master. So everything that the Ghost is going to do is just going to be on the replica, and the master's only just going to see, oh, something created some new table, and then it just started writing a whole lot of stuff into it, and it doesn't have anything to do with any other table at all. Well, that's interesting, right? Because like, what if we don't even like want that to happen on that master? What if we want it somewhere else? There's no reason that we would have to even keep it on the same cluster. We could use Ghost with that functionality to move the table to some other place, either while migrating it or while just doing like a engine equals NODB type alter, right? So that's kind of cool. This is what that would look like, right? Use Ghost to migrate a table, not just like migrate the structure of the table, but literally move the table somewhere else. Resurrection is something that fits with the theme of ghosts, right? If Ghost hits, that's good. You can. It's funny. So Ghost, if it hits critical load, or someone says like, hey, look, I throttled the migration, but I still think that like something, like it's bad, I don't know, Ghost is doing something wrong, and you just say like panic, it will kill itself, and then it would have to start over. But if we keep track of where Ghost was in the row copy and where Ghost was in the binary log, then we should just be able to resume that. And really, if we just know it was kind of up to here and we say, all right, well, We don't know if it was exactly at that point. It doesn't really matter because both of those things are idempotent. And so we should be able to just like start back up. Caveat here, we tried to do this. We started, and we were seeing some weird data inconsistency. So it doesn't actually work right now. We kind of stopped putting our effort into it because Ghost very, very rarely dies. And especially since we added an extra option to say like, hey, look, if you hit critical load and you're going to die, just wait 3 seconds, see if that load's gone, and if it is, then die. And so we would occasionally see like some other unrelated to Ghost spike happen, but it's gone in a few seconds, and so like not a big problem. I still want this to exist, but it doesn't. No. That's a question is somehow using pseudo GTIDs as part of the resurrection process. The answer is no. Interesting though. Interesting. Yeah. So there are a few things like on the table cutover, there's like, so there's nothing like a pseudo GTID like dropping a view that doesn't exist or anything like that. There's nothing like, so there's, the only things that we do are like actual things. So we'll inject like a heartbeat and then we'll look for it, or we'll like create the table and then we'll look to make sure that the table exists. There's nothing too complicated. The most complicated thing is the cutover section, which I don't want to try to remember exactly the order of that off the top of my head. But the reason that's complicated is because we have to lock the original table in order to make sure that no writes are going to it while we finish applying all the writes from the binary logs, and then we have to swap the tables. And if a table is being locked, you can't do that rename table where you put two and you flip them both at the same time. So it gets complicated, and there's like a third table that gets involved in another set. But don't worry about that, it works. We've tested a lot. And yeah, if you want to learn more about that, there's Shlomi wrote a really great blog post that describes it all. So I've got a few minutes left. I'm going to get through the rest of these slides. That's a new mug, contribution graph. People love it. It's going to be a lot of coffee. I think that there's probably going to be a lot of milk in that coffee because that's a big mug. It's like real big. So yeah. Ghost open source. It's out there under the MIT license, and we love to get collaboration on it. We've gotten community members filing bugs and asking questions and implementing features and sharing experiences. There are things that we don't do that other people do, and they have talked about it on GitHub. Yeah. Do we require a primary key? A unique key. It doesn't have to be a primary key, but it has to be unique. Yeah.
So how do you sync up with the application changes after you roll out the schema?
How do we sync up with the application changes after we roll out our schema changes? That's a very good question. Tom is going to be doing a talk on Thursday talking about sort of the automation around Ghost, everything that happens kind of outside of Ghost itself. So check that out. It is happening on Thursday at 12:50. So we've got coasters, yeah. And one second, I'll get to questions. Here's a sample. This will be in the slide so you can look at it. These are pretty normal. These are what something like PTL9 schema change is gonna have. And then here are some that are a little different. Things like switch to RBR. I mentioned we were running statement based, but we had some replica. I didn't even want to like bother to log into it. I've got 5 minutes, cool. So Ghost can like actually change something if you tell it, so that you have one less step. Yeah, so thank you. Ghost is available on github.com/github/ghost. Special shout out to the database infrastructure team, most of whom are here in this room right now. Check out these other GitHub talks and check out bit.ly/platform data because our platform data team is hiring. And yeah, thank you. Any questions? Also stickers. I've got stickers, and that is a sticker. Yeah. So the like what's the copy like is the question, right? What's the right? So that they're happening at the same time. So what's happening is Ghost is doing a where is it? It was early. So it's applying the events and copying the rows from the original table interchangeably. So yeah, it's a select star from this table. It reads all, well, it might not be a select star. It's like select every single column because then Ghost has to know what the columns are because you're changing some columns. But it's basically, yeah, select from one table into the other. Yeah, the selects happen in chunks. The chunk size is configurable. Yeah. Does Ghost work with Cloud SQL or RDS? Yes, and I'm not sure. So we don't use it with either of them, but I definitely know that folks have done it with RDS. Do you remember?
Yeah, it works with RDS with a couple contributors to help us out, figure it out, how to make that happen. There is a page of documentation that tells you what are the special steps to be taken on RDS.
But Google Cloud SQL?
I'm not sure.
Yeah,
No info.
I don't know.
If it doesn't work, let us know.
Yeah, yeah. If you're trying to do it and it doesn't work, then yeah, let us know. Yeah. No. Well, actually, no. There's check the repo. There are some issues that talk about Galera for sure. I don't know that I've seen anything about group replication. Yeah. Chuck. Yeah. Yeah, for sure they would. Yeah. So, yeah. So if you were doing tests and you were doing something on something and then you threw it away, like yeah, that box would have extra GTID transactions that would make it ineligible for promotion. Yeah. Sorry, could you repeat that? Is the original table dropped when you issued the cutover? The answer is no. It's possible that there's a flag that would let it do that. We don't because we have found that running a drop table is something that will cause a stall. So the way that we do it is actually by eating away at it in little chunks and letting it sit around for a while and then dropping it later. Any active work on supporting foreign keys? No, I don't think so. There is an option that says like, hey, trust me, there aren't any foreign keys. We don't have foreign key constraints in our databases, so we're not really. If you want to develop the support for them and send in a pull request, awesome. Yeah. Yeah. So any more questions? You can come up and chat. I've also got stickers to give away if you want that. So thank you all for coming.